Hello, and welcome everyone to the 15th webinar in Contact's Produce Safety webinar series. This second season continues to tackle fresh produce safety topics every month through a dynamic webinar series that will continue to bring together industry, academia, and regulatory minds to solve some of the produce industry's biggest and most timely challenges. This series is part of a larger industry outreach and risk mitigation project called Contact, or scientific challenges and cost-effective management of risks associated with implementation of produce safety regulations. This project is supported by the Specialty Crops Research Initiative from the USDA National Institute of Food and Agriculture. Any opinions, findings, conclusions, or recommendations expressed in this presentation do not necessarily reflect the view of the U.S. Department of Agriculture. This webinar series is part of a collaborative effort across 10 different universities and government institutions to enhance produce safety knowledge and compliance across the industry. We are so grateful to our collaborators for their efforts and support of this webinar series. You can see their logos on the screen. Dr. Michelle J. Russell from the University of California, Davis will discuss coexisting in your farming community while navigating the complex world of produce food safety. She'll be discussing this on Thursday, May 4th. Please join us for Won't You Be My Neighbor? This year's webinar series continues to address brand new topics chosen by you, so please fill out our evaluations or reach out. We hear you, and we are already brainstorming season 3, so drop us a line. We've still got an exciting list of webinars scheduled for this year, including retail case studies. If you think a topic is missing from the list, let us know in the comments, webinar surveys, or on our social media pages. While the webinar series lets us meet with you once a month, you know what I'm going to say. That's just not enough for us. We love to hashtag make contact with you about today's webinar or other produce safety news and research on our Twitter and Instagram pages. Follow us on these platforms at ps_sci. Be sure to check out the Contact website and our YouTube page for more produce safety resources, including our key takeaway documents, webinar recordings, and much more. Subscribe to our page to get instant notifications of content, like our soon-to-drop mini webinars. Since you all signed up for this webinar, you will get a special link to view Dr. Shauna Rock's mini webinar on hazards, risks, and her thoughts on chasing zero risk. It's pretty good, and it's less than 10 minutes. A quick reminder for today, if you would like to submit a question for our speakers during or before the Q&A session, please submit your questions through the Q&A box and not the chat box. Let's welcome our speakers today. Based in Charlotte, North Carolina, Natalie Dyson has responsibility for food safety, quality, and regulatory compliance across all Dole divisions worldwide. Before joining the Dole team in October 2016, she spent 8 years each at Walmart and Disney, where she held various roles in food safety and public health. Not to be outdone, she also brings with her Justin Kerr, founder of Factor 4 Solutions in 2013 to support ready-to-eat facilities with sanitation as a preventative control. This led to more work in the supply chain controls by early 2015, including efforts to manage sanitation of harvesters. Factor 4 Solutions is based out of California with employees in South Carolina, Texas, supporting over 200 customers ranging from field harvesting, cooling, processing in fresh and frozen vegetables, dairy, pet food, and meat processors. Welcome, Natalie and Justin. The floor is yours.
Thank you, Laura, and thank you to the Contact team for giving me the opportunity to talk a little bit about our lessons that we've had here at Dole from the front line of what's going on. So I thought I would start out with just a tiny little history lesson, because really the development of harvest equipment was driven out of necessity as demand grew. In the late 1870s, the Southern Pacific Railroad put a spur extension down into the Salinas Valley, which allowed farmers to start shipping their goods outside to other parts of the United States. At that time, it was mostly grain crops and sugar beets. But post-World War II, by the 1920s, they started producing lettuce. And by 1930s, iceberg lettuce was a huge commodity there. And it's actually really interesting here. This image is an actual article that was from a publication of the time that talks about how lettuce is becoming the major crop. And so this, along with some other things that have happened, have really created this need for the industry to develop something to help them meet the demand. So as the saying goes, necessity is the mother of invention. And when the lettuce industry started, this is how they harvested. This is a great photo from Monterey County Historical Society. And they were out there putting heads of lettuce in pine boxes and then stacking them and trucking them. And so as they needed more volume, because in 1922, they started shipping lettuce all the way to the East Coast in rail cars packed with ice, they needed to come up with harvest equipment. But this is the thing, the more things change, the more they stay the same. So here's a harvester from about 100 years ago, and the left and on the right is a harvester from Sweden that I took a picture of last year. You can see structurally the design is fairly similar. And the same goes for bulk lettuce. Here's a bulk lettuce harvester 100 years ago, and another one that was taken just 3 weeks ago. The design hasn't really changed much over the last 100 years, and it was never designed for food safety to begin with. But as is often the case, there's usually some sort of event that makes people say, oh, goodness, we should look more closely at this. And I'm sad to say that my company was the poster child for that. And it all started with a phone call 4 days before Christmas on December 21st at 4:30 p.m. with the FDA and CDC saying, we have been able to link from testing conducted in 2 different states, 2 different iceberg containing products that were produced at Dole facilities on opposite sides of the country, 7 weeks apart. They were made with raw materials from different growing regions, and yet they still found the same exact genetic strain of Listeria monocytogenes. So how is this possible? And after you get over the initial shock of hearing that information 4 days before Christmas, we pulled the team together, went into crisis management mode. And the first thing we asked ourselves was, how does the contamination get in the bag? Historically, Listeria has always been considered a facility contamination where the post-process contamination somehow introduced it in a processing facility, but we weren't so convinced about that. So we looked at the 2 ways. It gets in from the facility or it can get in from the raw material. And so our cross-functional teams collaboratively, we had 2 teams working on this, went down both of those paths simultaneously. So in the processing facility, we looked at things like, was the contamination linked to a specific wash line, to a specific scaler bagger, to an environmental contamination harbored somewhere in the plant, or did transferred equipment play a role? We were fairly confident going into this that it was none of the above, because in 2016, Dole had implemented a new environmental monitoring program. And from mid-2016 through the end of 2021, in the primary facility that was the focus of the investigation, we had more than 50,000 data points of swabs collected specifically for Listeria, showing that we didn't have an environmental source of contamination. The outbreak that the FDA and CDC alerted us to was a multi-state, multi-year outbreak going back to 2014. And I had, out of those 50,000 data points, only 0.32% of all swabs collected in that 5.5-year period were positive for any Listeria, and 0.05% of those were LM. So I was confident there was nothing, but we went on ahead and we worked side by side with the FDA. We did an investigation. We completely dismantled the plants, tore everything apart, collected just about 13,000 investigative swabs, and confirming what we already thought we knew, we found no evidence of resident contamination. There were no LM positives in the facility that was focused here on the East Coast. And then when we looked at the transferred equipment that had gone to other facilities, thinking that maybe it went from one facility to another, and that's how it ended up in 2 bags, we also found that was not a vector for contamination, because none of those swabs, when we took that equipment apart, were positive. On to our other investigation, and that was option 2. The contamination was introduced from the supply chain. And this was a cross-functional team. They looked for things like, was there a common raw material source used in both plants? Did the recycled pallets or corrugate that we use for the fiber bins with product coming in from the field, did they contribute to the contamination? Or maybe there was even a common piece of equipment used in the raw material for both lots. And that's exactly what we found. As we started going down and looking at all of our traceability data, we found that there was a common harvest crew that had harvested the product that was sourced in California, that was harvested in California, shipped to the East Coast, and used to make the bag of salad that the state of Georgia found to be positive in October. And then that piece of equipment went to Yuma during the transition, was used to harvest iceberg at the end of November. That was used in product that the state of Michigan found was positive for Listeria monocytogenes. As we had this cross-functional team there, we were able to learn from our business partners that the harvest crews usually use the same piece of equipment, and that narrowed us down to one particular rig. This rig. It's a funky perspective photo because I was standing in one spot taking a panoramic, but this is what was formerly known as the BL2. It's a bulk lettuce harvester. It's about 50 feet long. It's pretty complicated. It's got several very long, very heavy belts. I will tell you that this is the last known photo of this particular rig in existence, because shortly after this, it was cut up into tiny little pieces and sold off as scrap metal. But the team was focused on that piece of harvest equipment. And then in addition, we went back into the NCBI database to look at our outbreak cluster. And it actually showed that there were some genetically related strains from there within the Salinas watershed. So this is a screenshot of some of our little outbreak cluster from the database. And if you can see the items in red within the red circle, those are water sediment samples that had been collected at various points in time. And when you go into the database, you can access the GPS locations. And we did that, and we found that there were some of these samples that were collected just 450 feet upstream from one of the fields that we had harvested product out of in California prior to shipping that product to the East Coast. And that particular harvest rig in question had been in that field. So we felt like this was something that we needed to chase down. And the team went ahead and took investigative swabs. We took 109 swabs from zones 1 through 3 on this piece of harvest equipment, and 20 came back presumptive positive for Listeria. The cultural confirmation came back Listeria monocytogenes, and when we sent them out for whole genome sequencing, all 20 were an exact match to the outbreak strain. So at that point, we knew we had identified the root cause, the source of the contamination that accounted for the Listeria, the same Listeria, being in 2 different packages of product on opposite sides at different times. So moving towards the corrective actions, there were a lot of things that we learned during our investigation. The first was we realized there was a need to enhance the sanitation protocols. If you recall that piece of equipment I showed you, it's a long piece that has heavy belts. These belts are very difficult to lift and to clean under. They block access to some of the other parts within the machine, so it makes it very difficult to get in and clean. And then there is that whole elevator at the other end that's tall, and you need a ladder to access that, or standing on the flatbed of a truck. So we looked at that. We looked at how we could modify the sanitation equipment that we have. We looked at the process, the chemicals that we use, the sequence of the chemicals we use, and made some changes, not just in the harvest equipment, but also in other areas within our ecosystem, including the cooler operations. We added a field level verification for the sanitation. So we knew that we had a process that was capable of doing the cleaning or accomplishing the cleaning that we wanted to have done, but we needed to have some level of verification on the efficacy of the clean, because different crews clean at different times, and we want to have some sort of feedback so that we can know that the cleaning was done properly. ATP, there's good things, there's bad things of it. It's not a measure of microorganisms by any stretch, but it is really good to give an immediate feedback loop so that when you're out there with the sanitation crews, they can immediately see this is better than it was when you started, and it gives us some ability to start collecting a baseline so we know where we need to be from a clean perspective. We also knew after we took that BL2 unit apart and started looking more closely, it was clear that we absolutely had to adopt hygienic design principles for harvest equipment. As I showed at the beginning, harvest equipment design really hasn't changed a whole lot in 100 years. And the design was never designed thinking of food safety in mind. There might have been some modifications made in more recent years, but there had not really been a step change in how things were being fabricated. And so we've created a pretty robust hygienic design process. The team goes out and does hygienic design assessments. We made some major modifications on our equipment that Dole owns and operates. We also have worked with our third-party harvesters to do the same. We also added in a clean break for that equipment as we transition it going from one growing region to the next. So we have a new process now where the equipment is completely decommissioned. We dismantle it. We do a hygienic design assessment every single year, twice a year during this to see if there are any new modifications that need to be taken. We're assessing any new niche points that we didn't realize, obviously identifying any opportunities for repairs or enhancements. And then we swab. We do this D7 treatment, and I think Justin's going to get into some of the mechanics of the specific types of treatments and even verification protocols in his presentation. But we do this disinfectant treatment twice a year. We swab before, we see we're swabbing for pathogens, and then we swab after to see how the clean is to make sure that everything has, been cleaned to the level that we need it to be cleaned. And the D7 treatment, it's foam and a fog, and there are other treatments that are very similar, and it's been highly effective. Some of the key hygienic design changes that we've made in our equipment include looking at things like open channel frames where possible, going to a stainless steel open belt versus a solid belt. We've redesigned kind of those lift rungs on the elevator belt, those paddles that take the lettuce and carry it up so that it can be put into the bin. We've modified where possible the UHMW fasteners, trying to eliminate the needs for rivets or screws, and similar to what we have in our processing plant, make it a snap in, snap out if possible so that it's easy to remove for cleaning. Obviously, there's a focus on things like sanitary webs, niche or catch points, and obviously going back and eliminating unnecessary parts or attachments. A lot of these pieces of harvest equipment have been around for years, and we'll fabricate and we'll design something to do one thing, and then we'll decide, well, that doesn't work as well as we think, and so then we'll do something else. But sometimes those pieces and parts or attachments don't get completely removed. So I do have a few photos here, just as some examples of the changes that we made. On the left, you'll see traditional, this is what the harvest rigs look like. The sides are closed. There's difficult access. You can't really see below the belt. The belt is a solid belt. And so somebody has to try to lift it up and spray underneath it. A lot of times you only have maybe 2 people out at a harvest rig sanitation, so it's difficult to get in there. On the right, you'll see our modification. So we've opened up the side rails, so it's an open channel. It's no longer a pocket where things can collect in. The belt, we've removed that solid belt and gone to an open grate, if you will, a stainless steel belt. And it makes it very easy to access the areas below the belt to more effectively clean at the end of each day. Also looking at the belt, there's a couple of things we've changed. So right here on the left, you can see that there were Teflon belt glides, and those kind of get chewed up and scored and can become a harborage area, and we swap those out for stainless steel. We've also, like I mentioned, removed like little pieces that were left over because they were an attachment for something that we've removed, and taking care of modifications like that. Here's the elevator belts that I mentioned before. On the left, you'll see what it looks like. Each one of those paddles connects to the belt, and it creates a sandwich joint. So there's an opportunity for a potential harborage and niche area around each one of those little flaps. And so we've changed that, and we've made it, again, an open belt. And you can see that that upright part that catches the lettuce so it can go up is now open, just like the belt is. So some challenges and considerations as I wrap up for folks to consider as you're thinking about how you make some design modifications and obviously reduce the potential for future events to happen within your operations. A few things that we've learned is that Historically, I think we've always thought of harvest as the end of the growing cycle, but the reality is it's the beginning of the production process. The problem is it doesn't take place in a controlled environment. And so you have to go into how do you deal with harvest equipment design and sanitation with kind of a hybrid mindset. It's not a tractor. You can't clean it and treat it like a tractor, but it's also not a translicer or a scale in a processing facility. So you have to have kind of this hybrid mindset. How do you marry the sanitary design needs that you have from a production environment with the realities of the challenges of the fact that this is going to be out in the field. It's going to be going across fields through the mud. It's going to sit out there. You're cleaning it out in the environment. Another thing you need to think about are the structural design considerations. So again, in a processing facility, hollow tubing is a big no-no. That's something you shouldn't have because we know that hollow tubing can become harborage area potentially for listeria. However, in a harvest rig, the hollow tubing actually helps provide structural integrity and flexibility. So in a processing facility, we might use open channel or angle iron, but the problem is that doesn't give the same level of structural integrity as this harvest equipment is out in the field. It's flexing and torquing as it's going over uneven ground. And you need that hollow tubing to provide that integrity so that you don't start to get problems with the machine breaking down and having fracture points. In addition, hollow tubing is lighter than angle iron. And you have to consider not only do you need this to not sink into the soil while it's in the ground, in the field, but you also have DOT weight restrictions that you have to consider. These pieces of harvest equipment will go on the highways within a growing region and even between growing regions. And so you need to make sure from a weight perspective, you can meet that. Some of these rigs are upwards of 80 feet long, and the weight becomes considerable depending on the materials that are used to construct it. And then finally, you need to establish the appropriate definition of clean. As I mentioned, you're never going to get harvest equipment in the field to the same level of clean that you get in the production facility. You're never going to get to a less than 10 count on the surface of the harvest equipment as it's sitting there in the field. But what does that clean look like? And so we recommend take swabs, take ATP metrics, develop your baseline, and then use that data to have data-driven metrics on decisions and driving continuous improvement. You also need to make sure that you are validating your cleaning process. You need to make sure that the sanitation steps you have in place are actually capable of doing what you want them to do and getting the level of clean that you expect to get. And then verify that the process is being followed and verify that you're getting the efficacy with the clean that you're expecting to get. And with that, I will transition over to Justin.
Thank you, Natalie. Perfect. Thank you for everyone for attending and having the opportunity to present on this webinar. I think a great segue from Natalie's presentation into expectations that you might see in a facility are top standard of where you might be aiming with your program. And as you work through and the design of your equipment and rebuilding, constructing, and looking at new opportunities, you still have legacy equipment out in the field. So I'm going to go ahead and introduce some of the different types. I've tried to include harvesters other than leafy green because I'm sure there's some attendees that may be involved in packing, may be involved in other crops, may be involved in controlled environment growing. So harvesting is happening in a lot of different ways, and I'll go ahead and start with this. So first of all, geographically challenged. As Natalie said, they're set up with different teams looking over harvest that's happening in different areas. Different equipment, transfer of equipment. Graphically, we're looking at building programs that can stand with policy and procedures that can be executed in all the locations. And a lot of times the oversight on that, the people that are involved in managing that are stretched in a lot of different directions. Just field harvest sanitation's got the geographical challenges. We've got weather challenges, and this is an example of weather. All the efforts can be made, and looking at what the weather's doing and how things are set. I've been involved in a lot of great efforts being made, and then watch the wind come up and then start making a plan for, okay, what field is this harvester going to? How can we do rinse and sanitize prior? How are we going to manage the weather that we're extreme temperatures on some days, cold, hot? Those can all be challenges in cleaning. Time of day is a challenge. You start to look at sanitation out in the fields. Harvest is dictated by weather. Sanitation is the start of a good harvest, is a clean machine. A lot of that is occurring in dusk, dawn, in the middle of the night. Proper lighting, access to equipment that you can actually see and visibly, first step, visibly clean. A lot of times it requires extra lighting and positioning of equipment and whatnot. Space design and controlled environments. So as you start to look at what goes on in facilities, design of equipment, control over the growing, but then harvesting and having access to equipment can be a challenge, as we see lots of growth in that area. Location challenged on a muddy field or on a concrete pad. How are we getting after sanitation? What opportunities do we have to give ourselves the best benefit for cleaning? Lots of unique challenges with where the location of sanitation occurs. Numerous types of harvesters, some legacy equipment that's painted steel, that's maybe harvesting products that are intended to be processed further, not necessarily consumed as ready to eat, but as the table and what's being served changed, a lot of these unique opportunities to introduce products in as partially cooked or not cooked completely may involve equipment that needs redesign and thought and how it's pulled from the field. Just going through different types of harvesters right now. So this is a self-propelled versus a 3-point. These, where Natalie mentioned on their piece of equipment, 50 feet long. Some of these self-propelled pieces are over 100 feet long. Space and time and access. And we'll talk later about application of foam and sanitizers and drying and temperature and all that as well. Lots of different shapes, designs based on the crop that you're going. This is blueberries. So you get into some unique challenges and opportunities, and you get into some nice designs and things that all things are solvable. Sometimes things require more thought and more deep dives into what we can do to improve sanitation, but lots of good things going on. Again, furthering into types of harvesters, equipment, surfaces, chain link versus vinyl versus UHMW versus all kinds. So lots of different things going on. So I've got a lot of slides here. I might start talking fast. By all means, interrupt. Nat or Laura, just feel free if I start going too fast. Out in the field, learning opportunities versus on webinars versus reading documents and doing that. I think all these opportunities to improve our knowledge and understanding of the challenges out there will only help with food safety. This is an old picture. This is a fun one to look at. And when you look at it, there's a lot of things that go on when that sanitation truck pulls up to a harvester in a field. Proximity to other crops that are being grown, outhouses that are being cleaned and then maybe placed back in the field ready to use, corrugate, tote equipment that might be blocking access. So your sanitation employees that are out driving around many miles in between harvesters need to be organized and need to have a plan of attack and need to have hose links and positioning of pressure washers and chemical and everything in a way that they can find repeatability in their process. Trying to go basic, I'll do some deep dives, but I named the company Factor 4 Solutions after the 4 factors of sanitation. All policies and procedures should find time to validate and verify what opportunities they are using within the 4 factors of sanitation. Whether you're cleaning a lasagna dish at home or your car, you're using the 4 factors. In many cases, then you start to see you may not have access to one factor, so you rely on the others. Field harvest sanitation oftentimes is going to be limited on access to hot water, like many of our fresh processing plants, based on temperature controls, based on the environment. Doesn't mean you can't have hot water out there, but it adds in other factors of equipment, maintenance, and capabilities on diesel versus gas fuel and whatnot. So primarily, we're dealing with 3 factors out in the field: chemical, time, and action. For those that aren't aware with the 7 steps, this is just a slide to really look at your procedures and take a step-by-step approach. Dry cleaning and preparation of the equipment. When does a sanitation employee get to the equipment? Has it been idle for multiple hours? Did they just finish harvest? Has it been sitting there for 6 hours? So some of the dry cleaning and preparation may expand based on a 100-degree day in the South Valley of Salinas that harvest has been done for a few hours. You may have better opportunity to even have an air compressor and be able to knock dry leaves off of equipment before soaking them and sticking them back on. pre-rinse, the detergent application, scrubbing, then rinsing the detergent after scrub, visual inspection, and then ATP inspection post detergent, and then finally sanitizing the surfaces that you've cleaned. So we'll talk about water rinsing. It's a very important key. So water for field sanitation, heavy use of pressure washers because it's high pressure, low volume. What do we lack in the fields? Volume of water because we're trailing or trucking the water around. We talk about some other opportunities here as I go forward, but a lot of times selecting just the correct pressure washer tip can be very important because we're not necessarily trying to etch the surfaces that we're cleaning. We're trying to remove soil, just going out, verifying and making sure that the employees have access to what's probably going to be your higher use are going to be this 25, 40 degree or rotary nozzle or adjustable nozzle. We've done some experimenting with extensions because of some of the things Natalie mentioned with variable heights, and before things can be modified, we still need to clean them. Having access to that is very important. There is some use of lower pressure, higher volume out in the fields. And let me get back to my click through. So some examples of what might be available on a sanitation truck or trailer. You can purchase and run like a diesel heated washer. A lot of those are available on the market in the 3,000 PSI range, about 4.5 gallons. You may see an ambient type system that's at about 3,000 PSI with 5 gallon per minute. There are some instances like on chain link or interlocked for some of the spring mix tender leaf, where you may be better suited not to blast everything off with that 25-degree nozzle, but be able to flood the surfaces with restricting the hose. So you might get a pump. Calculations or the maintenance based on the head, water, feet, and pump out will then give you PSI and GPM capabilities. When you look at your process for rinsing, like Natalie mentioned, access the insides of the belts, getting the tension released, having the employees aware of how they can get to access certain areas, how the belt can be run and when the belt needs to be stopped. Always starting your process from the inside out what we've learned, because you have a long production day, the inside of the belts are going to gather product and that product is going to be ground down. So on shift changes, you might see a rinse out and sanitize. And in your sanitation process, you want to get that soil from the inside of the belt out first, and then start to focus on your exterior surfaces. Water source and volume, as I mentioned. So how far does your sanitation crew have to go to get their water tanks refilled from an approved water source? How much water is going to be used on each harvester? So these are things that we're out in the field working with customers on to find the right amount of time for rinsing, and then doing the math to add up if we're cutting corners because they've got to clean 6 machines. And if they go and grab their 500 gallons of water, is the last machine going to be shorted because they've got to drive 26 miles back to an approved water source? Just some quick math. If you had a 300 gallon water tank and you had 2 pressure washers using 4.5 gallons a minute, you're looking at about 33 minutes of available rinsing. Is that enough? Can you get the harvester clean? These are all questions that everyone should be asking themselves and of their capabilities. So sanitation chemicals for field equipment. So we start to talk about, and I don't want to go too far into depth because there should be access to numerous chemical vendors to support you and your needs for the field. So there's lots of variations. Historically, you've seen a lot of chlorine in water. You may have seen some kind of brute caustic or brute acid use. Some of these opportunities as we get going, we need to look at the periodic cleaning, the routine cleaning, the effectiveness of the detergents we're using. Do they rinse well? Do they have any surfactants or ability to hold the soils in temperature in the outside environments, or are they just quick to dry on and hold soils on the belt? So detergent type, soil type, and delivery. So an organic soil, you're most likely using a chlorinated alkaline detergent. If you're looking to get rid of minerals and soils related to hard water, related to the products that are being harvested and just the soil in itself, you may be using some acid detergents. And then you've got greases and oils that are going to be involved in harvesting. And so you may be looking at like an alkaline degreaser. There's some liquid and powder delivery methods for the chlorinated alkaline powder. You've got acid detergents, and degreasers are usually liquid. Lots of different ways to apply detergents and sanitizers, right sizing it. Natalie said 50 feet on the 3-point harvester on the back of a tractor. You get to some self-propelled that are 100 feet long. You get into some of the tender leaf or berry or green beans or carrots, and you're looking at a lot of surface area and a lot of niche areas where foam, misting, pump sprayers, and good old bucket and brush doesn't need to be forgotten, because sometimes that's the best way to keep surfaces wet and to work on focused areas. You have Venturi-based nozzles for washers, and you've got some flooded detergent applicators where you have a tank that's releasing detergent onto a belt while it's running, so an employee might be able to do other work. Titrating detergents and sanitizer concentrations, lots of opportunities out there, but understanding the detergent. So when you work with your chemical vendor, here's what I'm trying to clean, what's the best detergent or sanitizer to use, and then having verifications that you have the ability to properly mix it. If you're using Venturis, you've got the right orifices in there to draw the chemical at the right rate. So you should be looking at training and having the employees understand concentrations when they're cleaning. Here's an example of bucket and brush. The challenge is that you may need to have a day use tank or something that's pre-blended, so you can do a verification on 50 gallons of blended detergent. But a lot of times a bucket and brush can be a great way to get adequate scrubbing and surface cleaning based on the type of equipment. Access to the equipment. So Natalie brought it up. If you're trying to get leverage on a piece of equipment and you can only reach it at a high level above your head, you're going to be discussing and trying to figure out the right brushes, but you may be pulling a flatbed trailer up next to it. Or you could be looking at, this is a creative one. One of our customers has a platform built around it, so that the employee's up comfortably washing, rinsing, scrubbing, and whatnot. DOT was brought up on how you move harvesting equipment. Of course, you need to look at your DOT rules and how you can set up something if you're building platforms or access ways. A fire hose of information coming at you, but I know that this is being recorded, so I'm not going to go through the entire table, but you start to look at what is the piece of equipment I'm cleaning, what's the total surface area that I need to be able to apply a foam or a sanitizer to, and then selecting that equipment so that you can get detergent or sanitizer on all the surface repeatably at the desired concentration. A batch foam in the plant, we might see portable foamers. We have some operations that have air compressors and they're batching specialty detergents, maybe an acid detergent for multiple times during the week. And then during the rest of the week, they're using their Venturi because of their chlorinated water source. You want to work with your chemical vendors to make sure you're not mixing or having issues with chemical. You should have flexibility in your process. If you're designated to just one type of detergent application, what's a backup plan if the pressure washer dies? Is it that we're not going to clean and we got to fix it before we clean again? Lots of things to think about on design of applying detergents. Flooded detergent, these are some examples of how it operates or works. Here's a Venturi operation in a portable foam, so I can show just what you should expect to see when you're using them. And that's drawing off of about a 4,000 PSI washer that's got some equipment to slow down the pressure and increase the airless foam. And then a portable foamer being run, and I did a time lapse so that you could see ease of application, belts running, getting that good detergent coverage. Foaming detergents are, as you apply them, you're going to start to learn what the right consistency is based on the temperature, where you're cleaning, how it's going. You need to get surfaces covered. Same would go with, you're going to need to have brushes. So having color codes so that you're not cleaning direct food contact. Natalie made reference to that in their findings. There are defined direct food contact. There's going to be things that are not coming in contact with the product. Designing color code against your brushes. So selecting sanitizers, again, this is going to be available recorded. I'll just run through what's presently available for field sanitizing. So you've got your peroxyacetic acids, you've got your quaternary compounds, you've got blended. So there's some reference to the seasonal breakdown of equipment and heightened cleaning and disinfecting of equipment. So you see some of the peroxy detergents. Alcohol has been brought up a few times. There's a time and a place for it, but I'd caution everyone, you have flammability and you have a lot of these products are being hauled around on sanitation trucks. So make sure you're compliant with safety and transporting so you don't have containers expanding and exploding if they're sitting inside a field truck. Heavy reliance on chlorine as a sanitizer. And we're doing some more work and working with the silver dihydrogen citrate, where you have some neat learnings and opportunities for providing a zero health and hazard rating, ease of use with some residuals. So lots of different pieces here, tried to provide advantages and disadvantages of both. If you're dealing with some legacy equipment that's painted mild steel, and you're running another product, that you need to make sure you've got the right product so you're not causing further damage to equipment. So there's some emerging sanitizers. I definitely want to present that there's some encapsulated ozone. We're doing some work with some food grade coatings that have covalent bonding that has shown some residual that exceeds some of the standards. So continuous learning, talking to suppliers, learning about what you can do. A lot of harvesting equipment gets into a pretty repeatable pattern. And if you look at when sanitation occurs and when harvest starts, and transport of equipment, a lot of times there can be maybe a day or a day and a half in between. Chlorine dioxide, aqueous, and gas solutions have been used in the proper environment and use, have been beneficial as sanitizers as well. So just some quick little views of what misting might be with some of the emerging technologies, trying to show some examples on coverage. So that's quick for time's sake, just showing some things that are out there. So now we get into routinely verifying your sanitation of all results. You've got day in and day out cleaning that needs to occur, and then you're going to have periodic cleaning that's going to occur. So for all intents and purposes, on your routine day in and day out, you're going to be working with the same pyramid we'd use in the plant to learn how your equipment is. You're not going to be doing daily pathogen testing on harvesting equipment or routine. For all matters, work with your supply chain to understand where pathogen testing works in, but you should be able to establish a strong foundation of visual clean, organic load removal through ATP, which is super valuable in training employees. Aerobic plate count, EB, coliforms are all indicator pieces to show if you have microbial control over the equipment. And you may even start to look at your equipment and its possibilities of some biofilm building up. If you're not rotating detergents, you're not addressing niche points. You should have some means of verification, whether it's internal or external, but to go in and measure against what your procedure and policies state and what you're actually able to observe in the field when it's going on. You should be able to take that information and score it so that you can look at what crews or what pieces of equipment may be challenged, so you can focus your time and energy in the correct places. So now we'll talk about ATP and APC, as I previously mentioned in the pyramid. So ATP testing for soil removing and training. Trained thousands of employees how to clean. If you're working on an effort to encourage them to scrub harder, to scrub longer, to look at their detergent drying, segmenting the equipment in its process, ATP is a great tool to see if you're getting better each day. And then we use a lot of aerobic plate count to verify surfaces on a regular basis. And you can start to build a correlation, although it's not a direct correlation, but you can start to build, hey, the cleaner we can get a machine on a day-to-day basis, the higher likelihood we're going to have better micro results when we're doing our routine testing on that. So you're going to want to pick some routine testing locations. That doesn't mean those are the only spots you test, but you want to start to build trend data and understand your process and capabilities. Repeatability is the goal. This is an example of picking 5 areas where they're going to routinely sample, and then take an opportunity to identify areas that are problematic, design and infrastructure change, policy or procedure change. So if you don't have a complete understanding of ATP, this is a quick slide, but you want to make sure that when you're doing ATP and APC, that you're trained on your sampling methods, that you're taking like sample sizes, and that if you've assigned certain sample areas, that you understand everybody's going there. You want to understand a little bit that not all ATP is the same. So if you're trying to measure against what the plant's using or what you're using, work with your ATP equipment provider. Understand that it's taking a picture of the organic load. It's measuring the bioluminescence that's generated off the organic load. So there's different designs in the equipment, photomultiplier tube versus a photodiode. And you start to understand, am I taking a picture that's a Polaroid, or am I using the Canon Rebel to get a picture of what's going on? So lots of things to talk about with your provider on that. A lot of times we talk about failed ATP. we measure on first swab pass and then look at the corrective actions, brushing, scrubbing. In the field, the soil load's different. So when you get to a facility and you're using a scrub pad, a lot less soil is made it into the plant. When you're in the field, if you're in a high clay environment, a lot of times you'll see like a scrub pad start to plug up and it's smearing more than it's scrubbing. So you want to look at your ATP and see, hey, am I using the right tool to scrub? A lot of times improper rinsing of the surface can lead to high micro or high ATP. And you start to realize that's that conserving water. The employee says, hey, I've only got so much water left. I'm used to cleaning this amount of time, rinsing this amount of time. And if they short themselves on removing the detergent, you're going to see the ATP pop. So proper rinsing and attention to details. Why is this ATP? And start to look at like infield root cause. How come we can't get that number any lower? So here's an example of measuring performance and implementing solutions against ATP. This goes back into, I think, 2020, looking at April and May with a new harvesting machine, working on evaluating the procedure, implementing SOP training, looking at the detergents, using the flooded detergent application on tops of the belts, using a powdered detergent on the inside of the belts, looking at the periodic cleaning, when was it last taken apart, and then taking all those comparisons. And you can see here that there was some very high, and again, each meter reads different. This one was reading at 252,000 in April and May, up above 200,000. As those adjustments were made, you start to see the ATP drop down. Another quick example of trying to establish clean breaks between production. You can look at post-production. Numbers were up at 4 million on the metal chute. After just rinsing before detergent, 900,000. Post-detergent down to 15,000. So you're seeing good reduction, but can we get better? So again, SOP review, detergent changes, employee training, process flow, same piece of equipment, relatively the same amount of time to clean it. And we're able to see the achieving of 0 on the ATP, which is, hey, we got rid of organic load. If there's no food, no organic load, highly unlikely that we're going to allow that to continue to grow or have contamination risk. So these are just all examples, but how do you start to compile your information? You've got numerous machines you might be responsible for. Is the entire process getting over? So you can go machine by machine. This is multiple machines grouped together. You can look at your average, you can look at your median, you can look at those minimum and maximums. And so as you see here, 2021 into the summer of 22, you had some extremely high maximum ATP values. We saw those drop down. That's across the board. This is multiple harvesters over many days of sanitizing, probably we've got almost a year on the top, and then we're looking at 2 full months below 3. So taking the opportunity to look at the data, what's it telling you? Does this need to go in for fabrication changes? Do we need to look at our chemicals, our brushes, our pressure washers? What is it? Lots of cool ways to look at it. So here's an example. If this was live in Power BI, you've got historical. You can look at your first swab pass rate, go back to the date. You can look at weather, what was going on those days. Was it the same crew? Was it employee training? What was going on? So here's some aerobic plate count results. Each dot was a sample event, color coded over to the right. So those 5 locations with this customer, we took 1,000 and said, let's look at the items, why we failed or what the challenges were when we had an aerobic plate count greater than 1,000. So you start to look at it and say, okay, you can't take a huge bite out of the elephant, but you can start looking at what were the problems on these particular days. So as you start to go through and look at your sampling, you can see that this was like multiple machines being sampled on the same days. So there's gaps in between, and you start to look at and say, okay, can we get better over time? Can we decrease the amount of items above 1,000? And now with those customers, it might be, can we get below 500 and on? So looking at the data and working with it is a great tool to improve legacy sanitation on older equipment and justify costs and expense and revamping. Again, data, where were we cleaning? What were the results? We're doing some tracking of tools and equipment so we can set some minimum standards and then see what standards we're meeting and where we might be falling short. Periodic disassembly and cleaning, as Natalie talked about. So in between seasons, how do we access the equipment? Can we get it into a location where it's a lot easier to have a controlled environment for specialty cleaners and disinfectants. What does the equipment look like when we take it apart? And how much time is it going to be able to take all the belt guides off? And Natalie hinted at their changes, making things so that they require less time to disassemble, that they snap into place rather than bolting on. These are all improvements we can make. That clean break, seasonal verifications with swabbing, working with your supply chain on what data and information. When you take things apart, you start to notice things that can be improved. Welds can be ground down and redone. Items that are not in use, that were holding something together before, can be taken off. You may get into a situation when you take things apart where you start to see things like egging. Again, these harvesters are going through the field, up, down, a lot of slamming, heavy weight, lots of different things going on. We don't want to go and solve like an egging situation with a washer and a nut, because now you're looking at a niche area that has zero access in your routine cleaning. So all things to be looking for when you're doing those periodic cleanings. When you do periodic cleaning, you're in a controlled environment. You may have access to some things that you don't on your routine deal. So I'll just mention dry steam. There's the application of the steam to the surfaces, but there's also tarping off, bagging, and raising and holding temperature with dry steam to benefit the equipment that's being bagged off. Similarly, dry ice is a tool we've used in packing houses, and there's some opportunities if you don't purchase the equipment. There's some others that will lease equipment for short periods. So if April is a transition time and you have access to it, you can use dry ice. This was in a packing cup for avocados. You can see the soiled cup versus treated. This one's got a hole blown in it because they had the pressure too high, then trying to bring the pressure back down. And you can see the removal of discoloration on a box conveyor. Chlorine dioxide gas is another tool we've used on harvesting equipment. You can bag off that equipment. You can bag off brush beds if you're in a packing house, and you can do a treatment on a clean brush where you're getting that extra treatment. So lots of different chemical vendors, suppliers, people you can be talking to about how you can tackle the periodic cleaning. This is just a slide on the effectiveness of the chlorine dioxide, molecule size versus the organism. Again, talking to your vendors, asking for what the opportunities are to increase your separation between seasons and fields and equipment. So I'm talking fast, but hopefully this is good information. Take into consideration all things now at the end. Harvester location, where was it cleaned? Natalie showed their portrayal of root cause, getting all the way back to a harvester, what activities, and then how to go forward. Albert Einstein, information is not knowledge. And if you look at this pyramid, you're going to collect data, you're going to have information. But for those of you attending this call and looking at this information, you may be tasked with how you take the information and create knowledge and action in your operation. So it's not a small mountain to climb, but just getting things piled up on your desk through all the various means now with electronic transfer of records and whatnot, you need to be able to funnel it down and say, if we're getting the results that we don't like, how do we create training, knowledge, procedural changes, and then implement the action? This is just a sympathetic piece, but this was showing the history traveled of a harvesting machine up and down the Salinas Valley in the red lines. On the blue dots, those are where the sanitation events occurred. We're doing some stuff on some applications on your phone so that you can see specific events. And if you're moving from one field to the next, make sure that machine was clean so you're not taking field A to field B. Lots of different technology and things out there. We're trying to provide ways to get information through APIs, pass through various technologies so that you can take a snapshot and look at a particular field. Where did the sanitation events occur? Why did some occur in some spots? And why is there a cluster down at the bottom where most of them occurred? And you can go back and look at historically, are we getting better results when we're over here because we have better access to the machine versus in the field or in the beds? So lots of cool things out there and available. And this is like satellite imagery that some of the technologies out there where you can use some applications to look at historical growth on the field where the density of product unharvested or harvested was. So when you look at it, whether you're recording it electronically, if you're using some of the technologies out there, or if you're manually doing it, what were the times in motion? What was the actual cleaning? What was going on? What tools were missing if you're recording data? So you go out and watch a wash and realize that they had lost a brush in the parking lot at the gas station. How did that affect your capabilities to get repeatable clean? So in the end, you're going to have capability to organize your data. You may kind of in a standard deviation curve, look at how you tighten up clean, but then how do you make sure that clean matches up so that you don't have spread out different successful events, but they all line up and that you can show repeatability. You have a stable process. That's my slide deck. My information's up there, and happy to say Factor 4 Solutions turned 10 years old in July. And it's because a lot of the people are probably listening here and all the opportunities like this to get out, do hard work, and try to share that information.
Thank you so much. I want to thank you. Kept a really big audience, lots of questions. We probably need to come back with a part 2 at some point. Sanitation is important. For everyone that stayed with us, thank our speakers. Thank you both so much. And we hope you join us next month, May 4th. So will the 4th be with you? I had to have some joke. Won't you be my neighbor? We're really going to tackle this interface between our farming community and navigating the world of produce food safety. It should be an interesting topic since we just talked a little bit about watersheds, farming environments, and that intersection. So thank you all again, and we'll hope to see you next month. Justin, Natalie, we appreciate it.